what is resolution of a vector. Actually, if you have any vector, you can write that as a sum of other vectors. Okay, so that is basically resolution of a vector. So before doing that, we need to learn an important concept called as unit vectors. So first we'll do that. So what are unit vectors? Unit vectors are vectors having magnitude 1. That's all. Simple. Why are we seeing about this vector? Because a unit vector is a very useful vector because it can be used to represent a direction. Because since it has a magnitude of 1, it can be used to create any vector in that particular direction. So why are we studying these unit vectors? By having magnitude 1, this unit vector can represent a direction. Okay, because we know that it has a magnitude of 1, so we can use that to represent a particular direction. And if I multiply a number to that, I can create whatever vector I want in that direction, right? If I want a vector of magnitude 5, if I multiply 5 to this unit vector in that direction, so won't I get a magnitude 5 vector in that particular direction? Yes, I will get. Okay, so basically you can scale this unit vector to produce any vector in that particular direction. How this unit vector becomes a unit vector, okay, or how to produce a unit vector if I know a general vector. Okay, for example, let us have a vector called as a, and I'm telling that the magnitude of vector a, that is a, equals to 5. Imagine that this arrow's length is 5 units. Okay, this arrow's length is 5 units. What if I divide this arrow's length into 5 equal parts? That is, I divide this arrow's length into 5 equal parts. 1, 2, 3, 4 and 5. Imagine they are all equal. Okay, so that means each part has a magnitude of 1. That is, each part has a length of 1. Okay, so therefore each vector can be taken as a unit vector, or this particular part, or in this particular part you can take this also. This particular part having magnitude 1 can be taken as the unit vector in that direction. So therefore, how to create unit vector? By taking the vector a and dividing it with its own magnitude. Okay, so if you want a unit vector, take a vector and divide it with its own magnitude, so that you'll get a unit vector in that direction. Okay, because if I divide it with 5, what happens? The vector becomes 5 times smaller. We saw this in multiplying a number with a vector. Okay, if I multiply 1 by 5 with the a vector, that will shorten the vector to 1/5 of its original length. What was the original length? 5. So what is the 1/5 of the original length? 1. Okay, so therefore I'll get a vector of magnitude 1 and in the same direction. Okay, so how to represent that? I can represent that using a cap. All the unit vectors generally are represented like this, using a cap symbol. Therefore, how to create a unit vector? Take a vector and divide by its own magnitude, so that you get the unit vector in that direction. Okay, so if I want a different vector, b vector, in the same direction as the a vector, okay, and b's magnitude should be 10, what I have to do? I just have to find the unit vector of a and then multiply 10 to that unit vector, such that 10 into a cap gives us the b vector. Okay, because I want a b vector to be in the same direction as a vector, but with the magnitude 10. Okay, so I'm multiplying 10 with the a cap, so that will give me b vector to be 10 into a cap. Okay, that's how you create new vectors using unit vectors. So now, how is this unit vector concept useful in resolution of vectors? Previously, I told you that you can write any vector as a sum of two vectors, right? If I have a vector like this, I just have to write this as a sum of two vectors. So to generalize, so I can take any two vectors. Okay, for example, take this vector and take this vector. So if I add these two vectors, according to triangular law of addition, I'll get the original vector. Yes, that's possible, but this is not a good way to do this, right? Because if this is possible, this is correct, but this is not the good way. But how to do this in a very repeatable way? That is, I should be able to do that method with any vector, so it should be a generalized one. To do that, I'm taking the x and y axis. Let this be y axis, this one x axis, this one negative y axis, this one negative x axis. I have the vector. Now I have kept the vector at the origin. How to represent this as a sum of two vectors? That was our original goal. So now what I'm going to do, I told you that any direction can be represented by a unit vector. X-axis is also a direction, right? So it should also have some unit vector, right? The x direction unit vector can be taken as I cap. Okay, just for naming sakes, I have just written as I cap. You can keep it as anything you want, but generally people use I cap for the unit vector of x direction, and for y direction, I can take the unit vector to be j cap. Now, why have I written this x and y axis? Simple, you just drop a perpendicular from the head of the vector to the x-axis. So this becomes the perpendicular. And let the vector make an angle theta with respect to the x-axis. And let's call this vector to be vector A. And the magnitude of the vector be A. Fine. So the length of this arrow mark is A. So according to trigonometry, can we write this side from O to this point to be A cos theta? This length from this point to this point, and from the head to this point, can we call that as a sine theta? Yes. Now if this length is a sine theta, now I'll draw a parallel like this. This length is also a sine theta, so this length is a sine theta, so this length is a cos theta, this length is a sine theta. Now why have I written this? Now let's call this point to be point B. This is point A, this is point C. Why have I written this? Because can you see some resemblance for this structure to the parallelogram law of addition? Because both are same. See, OB if it's a vector and OC if it's a vector, then OB vector plus OC vector is nothing but OA vector, that is A vector, from parallelogram law of addition. Because from the two heads of these two vectors, I have drawn a parallel line. See, parallel line to each other. So those two parallel lines meet at this point A, and if I join the O and A point, I am getting the A vector. Therefore, if I add OB vector and OC vector, I'll get my A vector. Okay. So OB is a vector in the x direction and OC is a vector in the y direction. What is the magnitude of OB? Magnitude of OB is A cos theta. We just have written that already. O to be the length is A cos theta, and magnitude of OC is A sin theta. So I know the magnitude of the vector, I know its direction, I know it is in the x-axis, and I know OC is in the y-axis. Can I write that in terms of the unit vectors I cap and j cap? Yes. How? From the unit vector formulation, we know that if I know a unit vector of a direction, I can make any vector in that direction with any magnitude I want. Okay. So similarly, here I know the unit vector in the x direction. I want a vector OB such that its magnitude should be A cos theta. It should be in the x direction. Therefore, OB vector can be written as A cos theta into I cap, and OC vector can be written as A sin theta into j cap. So now I can represent A vector to be A cos theta I cap plus A sin theta j cap. So therefore, A vector equals to A cos theta I cap plus A sin theta j cap. And that is called as the resolution of the vector A in terms of I cap and j cap. So we have written the vector A in terms of its x component, and y component. Okay, so we call this as the x component of the vector A, and this as the y component of vector A, and this is basically resolution of a vector in 2 dimensions. Okay, because we have taken only x-axis and y-axis. What about the z-axis? So if I take z-axis, the formula will be little different. Okay, and we'll see that also in a minute. Before that, using this resolution of a vector formula, how to generate the magnitude of vector A? Magnitude of vector A is A. So therefore, how to find the magnitude of the vector A? If I know the x component and the y component. So this is x component and this is the y component. So let us call this as ax and this as ay. Okay, so if I know ax and ay, how to find a? So if we go back to this diagram, see, this length is OB is ax and this length AB is ay. So since it's a right angle triangle, from Pythagoras theorem, can I write a equals to root of ax square plus ay square? So that implies root of a square cos square theta plus a square sin square theta. So obviously if I take a square common outside, it will become a square into cos square theta plus sin square theta, and automatically you'll get a again. So this is the formula for finding the magnitude of vector A using its components, x component and y component. Okay, if it is in the xy plane. See this picture in a clear way, you can also say that a cos theta, the x component of a vector, is nothing but the component of this vector A along the x-axis, and a sin theta is also the component of vector A along the y-axis. We saw that, but we know that if this angle is theta, what about this angle? This angle is 90 minus theta or pi by 2 minus theta. Okay, so if this is 90 minus theta, there is an angle between the y-axis and the vector A. Then what is the y component? Y component is a cos 90 minus theta. So in that way, the y component becomes a sin theta. So you can find y component like this also, however you want. I am telling you this because we will use this concept in finding the components of a vector along the 3 dimensions, the next part. Now, let us see the component of a vector along the 3 dimensions x, y, z using this graph. Let this be y-axis, let this be x-axis, and this one z-axis. Now, let us have a vector from the origin like this. Okay, you can now ask me, will I have all my vectors in the origin itself? No. Okay, you can have a vector like this also, but you can move that vector to the origin. Okay, because vectors are free vectors. Okay, generally vectors are free vectors except in few cases, because you can move around the vectors wherever you want. Okay, in some cases you cannot do that because it will be different. For example, if you want to find the torque acting on a body, then you should not move the force vector wherever you want, because that will change the torque. Generally, in most of the cases, the vectors are free vectors. Wherever you want, you can move it, but in other cases, you should not. So I am moving this vector to the origin, so that I can find the components of the vector. Now, how to find the components of this vector A? Simply, for that, I should know the angle it makes with the x-axis, that is theta 1, the angle it makes with the y-axis theta 2, and it makes with the z-axis theta 3. So if I know theta 1, theta 2 and theta 3, then I can easily find the x component, y component and z component. We have seen how to find the component of a vector along any direction. So the x component will be a cos theta 1 and y component will be a cos theta 2 and the z component will be a cos theta 3. So now we already know that the unit vector along the x-axis is I cap and along the y-axis is j cap, and the unit vector along the z-axis is actually k cap, and now I am introducing it. So now, as an extension to the two-dimensional case, I can write the vector A to be the summation of the 3 components. Okay, so it is a x I cap plus ay j cap plus az k cap. what is this? A cos theta 1 I cap plus A cos theta 2 j cap plus A cos theta 3 k cap. So this gives us the formula to represent a vector in its three-dimensional components. If you want to find the magnitude of vector A by just looking at the components of it, you can just use this formula. That is root of ax square plus ay square plus az square. This is just an extension from the two-dimensional case. Okay, so this one and this one can be used to represent any vector in its three-dimensional form. That's it. So, for example, if I have a vector A of magnitude 10 units and let it make an angle theta to be equals to 37 degrees, and I have to find the unit vector and I have to find the resolution of vector A in terms of I cap and j cap. Let us find out. So this is the angle it makes with the x-axis. Okay, so therefore what is A vector? Ax I cap plus ay j cap, and that is nothing but A cos theta I cap plus A sin theta j cap, and I know that 10 is my A, therefore A vector can be written as 10 into cos 37 degrees I cap plus sin 37, 10 into sin 37 degrees j cap. Now you have to know the value of sin 37 and cos 37, and actually you should know for 53, sin 53 and cos 53 as well. See, I'll write it here. Cos 37 and sin 53 both are equal, and that's equal to 4 by 5, and sin 37 is equal to cos 53 is equal to 3 by 5. So this you should know, and applying that here, A vector becomes 10 into 4 by 5 I cap plus 10 into 3 by 5 j cap. That gives us A vector to be 8 I cap plus 6 j cap. So if you want to make sure, you can just find the magnitude of vector A again. That is root of 8 square plus 6 square, that will give you 10. And that's how basically you resolute a vector in IJK format. You may ask me, why are we doing this? Why to represent a vector in its IJK form? The answer is, if you represent a vector in its IJK format, it is easy to add two vectors, subtract two vectors, and we'll learn how to multiply two vectors also. There are two types of multiplication, that is vector product and scalar product. For those things and all, the IJK format is very useful and it's very easy to do addition and subtraction. So let us try to do addition and subtraction in this. Let us take an example. A vector to be 2 I cap plus 3 j cap plus 5 k cap. I am taking some random numbers. And B vector to be 10 I cap plus 5 j cap minus 7 k cap. How to add these two vectors? The vector A plus vector B can be found by just adding the corresponding elements. That is, the x components, add the x components together, add the y components, add the z components. That's all. So A plus B can be written as 2 plus 10 will give you 12 I cap plus 3 plus 5 will give you 8 j cap, and 5 minus 7 will give you minus 2 k cap. And that's how you add two vectors in IJK format. And subtraction is also very easy. What is A minus B? A minus B can be written as, you subtract the corresponding x component, y component and z component. So 2 minus 10 you should write. So 2 minus 10 is minus 8 I cap, and 3 minus 5 is minus 2 j cap, and 5 minus of minus 7 is, so minus of minus 7 become plus 7. So it will be 5 plus 7 will give you 12 k cap. So this is the subtraction of these two vectors. Previously we saw how to add and subtract two vectors. Okay, that was little difficult than this, but this is very easy, and we found the resultant vectors in both the cases. And if you want the magnitude of the resultant vector, just take the magnitude of this. Here r becomes root of 12 square plus 8 square plus 2 square. That's all. Okay, you can ask me, here it is minus 2. Why am I squaring 2 here? Because if you square minus, it will become plus, right? So you don't have to include that minus here. So here also the resultant vector's magnitude becomes 8 square plus 2 square plus 12 square. You just take the magnitude of the each component and square it. That's it. So it's 12 square, right? Okay, so add them together, take the root, and you'll get the magnitude. We will use all these concepts while solving questions. These are just illustrations. Okay, these are not actual questions. These are just illustrations. If you are having any doubts regarding any concept, just leave it in the comments, and I'll try to reply to everything. And if you haven't done yet, click the subscribe button for more such content.